The Dyson 360i robot is powered by the high-speed Dyson digital motor. It's small and light, yet delivers higher suction than any other robot vacuum. A unique 360-degree vision system sees all the way around itself at once, selecting reference points to track and triangulate its position so it knows where it is, where it's been, and where it is yet to clean, systematically cleaning your home in 3-meter grids. Patented radial root cyclone technology generates powerful centrifugal forces to fling dust out of the air and into the bin. The robot's cleaner head spans the full width of the machine. Carbon fiber filaments remove fine dust from hard floors, and stiff nylon bristles remove ground-in dirt from carpets. Continuous tank tracks climb over obstacles and maintain speed and direction, ensuring it stays on course. And the Dyson Link app allows you to start, pause, and schedule your cleans, as well as monitor and update the Dyson 360i robot vacuum. The Dyson 360i robot, the most powerful suction of any robot vacuum.
So on the Dyson 360i robot, we chose to use vision because it means the robot can know exactly where it is within a room very accurately. In turn, that means that the machine can clean very efficiently and systematically. So when we were developing the camera systems, it was very clear that there wasn't an existing system we could just use. We very quickly decided not to use a forward-facing standard camera. What was needed was a system that can see all around the machine all at the same time. The advantage of such systems is you don't need to physically turn around to look to see where you are. And the other thing is anything that comes into view doesn't obscure the whole image, so the robot isn't easily blinded. So this is an example of the panoramic image used by the robot to navigate by. One of the main advantages is all 4 sides of the room are visible in a single shot, so the robot doesn't have to continually turn itself to actually see where it's going. It will take high contrast features throughout the image and use those to triangulate its position. As the robot begins to move, one of the advantages is those features can be tracked throughout the image without ever going out of shot. So the navigation system is very clever. Whilst it's actually using a map to localize itself, it also has to create that map. At the same time, infrared sensors detect where objects are and place those on the map so that the machine can avoid objects and systematically plan its way around the room to ensure methodical cleaning. So the cleaning pattern is very simple. The robot only ever wants to travel within one robot's width of where it's been before. What that means is, as the robot moves around, when it gets to a location such as this, it doesn't go forward, it now needs to turn to maintain that. Eventually, the robot expands into a square spiral pattern. At no point in that clean has the robot ever been more than a robot's width away from where it was before. This means the robot is gradually and systematically cleaning the room without having to cover back over locations it's been before, which is wasting time. Of course, in real homes, there are obstacles. What would happen in this situation is the machine carries on its spiral pattern. As it approaches the object, it slows down, steps across one robot's width, and comes back in the opposite direction. If it encounters further objects, which effectively trap it in, it will carry on cleaning until it can go no further, and then make a sensible decision as to the next nearest point to resume cleaning. This is only possible because the robot has an internal map, it knows where it's covered, and it knows where it's left to be cleaned.